Welcome to tonight's journey of discovery and peace. Close your eyes and breathe in very slowly. Let the weight of the day simply fade. We are traveling far beneath the ocean surface. The sun cannot reach these extreme aquatic depths. Total darkness embraces the quiet ocean floor tonight. Here lies a hidden world of hydrothermal vents. These deep cracks release heat from the earth. Tonight we will explore 100 fascinating facts. This is the first part of our journey. We will cover the first 10 incredible discoveries. Settle into your bed and relax your muscles. Imagine sinking gently through the cool dark water. The pressure builds quietly around our submersible vessel. A soft hum vibrates through the thick glass. Outside the window, absolute blackness fills the sea. We are descending toward the active volcanic ridges. This environment seems completely hostile to human life. Yet a vibrant ecosystem thrives in the shadows. Let your mind drift down to the seabed. Our peaceful exploration of the abyss begins now. You are safe and warm in your cozy bed. Listen to the steady rhythm of my calm voice. We will uncover the quiet secrets of the deep. Fact number 1 begins with an unexpected discovery. Scientists first found hydrothermal vents in 1977. A submersible named Alvin explored the Galapagos Rift. Researchers dove 2,500 meters below the waves. They expected to find a barren ocean floor. Instead, they discovered a thriving underwater biological community. Geologists originally went looking for underwater temperature anomalies. They towed a sensitive thermometer near the seabed. The water suddenly registered a massive heat spike. Alvin descended to investigate this strange thermal reading. The crew saw shimmering water rising from rocks. Clams and pale crabs surrounded the warm crevices. This single event changed marine biology science forever. Nobody knew life could flourish without any sunlight. The 1977 expedition rewrote science textbooks globally. It proved that geothermal energy could sustain ecosystems. Fact number 2 explores the extreme vent temperatures. Black smoker vents produce incredibly hot toxic fluids. The water temperature can reach 400 degrees. This is roughly 750 degrees Fahrenheit. Under normal surface conditions, this water would boil. However, the immense ocean pressure prevents any boiling. At 3,000 meters, pressure is extremely high. It is 300 times greater than surface pressure. This intense weight keeps the superheated fluid liquid. The water shoots upward at very high velocities. It travels at 1 to 5 meters per second. The fluid carries dissolved metals from the crust. When it hits cold seawater, minerals instantly precipitate. This chemical reaction creates dark billowing mineral clouds. These mineral clouds give black smokers their name. The surrounding seawater remains near 2 degrees Celsius. This creates a massive temperature gradient within centimeters. Fact number 3 reveals the secret of survival. Sunlight provides energy for most life on Earth. Plants use photosynthesis to make food from light. Deep ocean vents exist in total absolute darkness. Therefore, vent ecosystems rely entirely on chemical energy. This fascinating biological process is known as chemosynthesis. Specialized bacteria live around the hot vent openings. They consume toxic hydrogen sulfide from the water. This chemical smells exactly like rotting chicken eggs. The bacteria convert this sulfide into organic matter. They act just like deep ocean microscopic plants. These microbes form the base of the food web. Larger animals consume these bacteria to survive here. Some creatures even grow the bacteria inside themselves. This symbiotic relationship allows giant communities to thrive. Chemosynthesis produces energy without a single photon of light. It represents an entirely separate tree of life. Fact number 4 introduces a unique vent field. Scientists discovered the lost city in 2000. It sits on the Atlantis Massif underwater mountain. This location is in the mid-Atlantic Ocean. These vents differ greatly from typical black smokers. They do not produce dark iron sulfide clouds. Instead, they emit highly alkaline transparent warm fluids. The fluid temperatures only reach 90 degrees Celsius. The structures are made of pure calcium carbonate. They look like pale white limestone ghost towers. The tallest chimney reaches 60 meters in height. Researchers named this massive structure the Poseidon Pillar. The lost city vents operate through serpentinization reactions. Seawater reacts directly with exposed mantle rock below. This process naturally generates hydrogen and methane gases. Tiny microbes feed on these specific carbon compounds. These white towers grow very slowly over millennia. Fact number 5 focuses on an extreme survivor. The Pompeii worm is a remarkable deep creature. Its scientific name is Alvinella pompeiana in Latin. French researchers discovered this worm in 1980. It lives directly on the sides of black smokers. This animal tolerates the highest marine creature temperatures. The worm builds a protective tube from minerals. Its tail end rests near the boiling fluid. The tail experiences temperatures near 80 degrees Celsius. Meanwhile, its head sticks out into cold sea water. The head remains at 20 degrees Celsius comfortably. A massive temperature drop exists across its body. The worm measures only about 13 centimeters long. A thick layer of bacteria covers its back. These bacteria act like a thermal insulation blanket. They protect the worm from the searing heat. The worm secretes special mucus to feed the bacteria. Fact number 6 examines the lifespan of vents. Hydrothermal vents are not permanent geological ocean features. They are actually highly unstable and short-lived. A typical vent field lasts for several decades. Some vents only remain active for 10 years. Earthquakes frequently shake the active mid-ocean ridges. These tremors can easily alter underground plumbing systems. Tectonic shifts may block the flow of hot water. When the fluid stops, the vent community dies quickly. The surrounding cold water reclaims the mineral chimneys. However, new vents frequently open in nearby locations. Vent organisms must colonize these new thermal springs. Microscopic larvae drift along the deep ocean currents. They travel hundreds of kilometers through the dark. Eventually, they settle on a newly formed chimney. This cycle of destruction and rebirth is continuous. Fact number 7 details the giant tube worms. Their scientific name is Riftia pachyptela in biology. These worms grow up to 2 meters long. They live primarily in the eastern Pacific Ocean. These creatures possess a striking bright red plume. The red color comes from complex hemoglobin molecules. This special blood binds tightly to hydrogen sulfide. Surprisingly, adult giant tube worms lack a mouth. They also have absolutely no digestive tract inside. Instead, they rely entirely on an internal organ. This large organ is called a trophozoan structure. Billions of symbiotic bacteria live inside this tissue. The worm's blood delivers chemicals directly to them. The bacteria produce sugar to feed the giant worm. These tube worms grow faster than typical marine invertebrates. They can grow 80 centimeters in a single year. Life flourishes quietly in these deep, dark places. Fact number 8 concerns the massive mineral deposits. Hydrothermal vents act like natural underwater mining factories. The superheated fluids dissolve metals deep underground daily. They carry iron, copper, and zinc toward the surface. Cold seawater causes these metals to solidify instantly. The falling minerals slowly build towering chimney structures. Some chimneys grow up to 30 centimeters daily. Over thousands of years, massive sulfide deposits accumulate. These deposits contain highly valuable rare earth elements. Ancient vent deposits now exist on dry land today. Tectonic forces pushed these ancient seabeds above water. Many modern copper mines originated as hydrothermal vents. The island of Cyprus holds famous ancient vent deposits. These geological formations are millions of years old. Mining companies now look toward active ocean ridges. Scientists urge caution to protect these unique habitats. The mineral towers stand as monuments of deep time. Fact number 9 introduces the fascinating Yeti crab. Marine biologists discovered this crustacean in 2005. They found it near the Easter Island microplate. The depth was 2,200 meters down. Its scientific name is Kiwa hirsuta in taxonomy. The crab measures roughly 15 centimeters in length. It completely lacks eyes due to the total darkness. Its most striking feature is its hairy white arms. Dense pale bristles cover its long front claws completely. These unique bristles are formally known as setae. The crab uses these hairy arms to farm bacteria. It waves its arms slowly in the vent fluid. This gentle motion bathes the bacteria in chemical nutrients. The crab then eats the bacteria it carefully grows. It uses specialized mouth parts to harvest the crop. This creature represents an entirely new animal family. The discovery highlights the mysteries of the deep sea. The Yeti crab dances silently in the warm waters. Fact number 10 connects vents to outer space. Hydrothermal vents might exist beyond our own planet. Scientists look closely at icy moons orbiting gas giants. Jupiter has a frozen moon known as Europa. Saturn has a small icy moon called Enceladus. Both moons hide massive liquid water oceans underground. Thick ice shells cover these deep alien seas. Spacecraft detected silica particles erupting from Enceladus recently. These tiny particles strongly suggest active hydrothermal vents. The rocky cores generate heat through tidal friction. This heat could easily power deep alien black smokers. Astrobiologists believe these vents could support extraterrestrial life. The conditions mirror Earth's deep oceans perfectly today. Life on Earth may have started at such vents. Therefore, alien microbes might swim in those distant oceans. Future space missions will search for these chemical signatures. The deep sea connects us to the vast cosmos. As you drift to sleep, imagine those distant oceans. Our journey through the abyss will continue next time. Fact number 11. Hydrothermal vents create extreme temperature gradients deep underwater. The superheated fluid reaches 400 degrees Celsius. Surrounding ocean water remains near 2 degrees Celsius. This massive temperature shift occurs within mere centimeters. The boundary layer is incredibly thin and sharp. Organisms navigate this microscopic thermal divide every day. A creature might experience freezing and boiling simultaneously. Scientists measure these gradients using specialized titanium probes. The probes record temperature changes millimeter by millimeter. Thermal mapping reveals a highly fractured fluid environment. Cold seawater constantly mixes with the boiling plumes. This mixing zone triggers rapid mineral precipitation processes. Dissolved metals instantly solidify into dark floating particles. The resulting smoke obscures the immediate surrounding area. Visibility drops to absolute zero within the mixing zone. Researchers rely on sonar sensors to navigate safely. The extreme heat does not destroy the local ecosystem. It provides the fundamental energy driving biological processes. Life flourishes exactly at this razor-thin thermal margin. The steady flow creates a highly stable microclimate nearby. This stability allows delicate organisms to thrive continuously. Fact number 12. Chemosynthesis operates very differently than surface-level ocean photosynthesis. Solar energy never reaches these profound ocean depths. Vent bacteria extract energy directly from hydrogen sulfide. This chemical process is inherently less energy efficient. Photosynthesis captures sunlight with truly remarkable biological precision. Chemosynthesis yields significantly less energy per molecular reaction. However, the chemical fuel supply never stops flowing. The vent system operates continuously without a night cycle. Bacteria synthesize organic carbon 24 hours a day. This constant production offsets the lower metabolic efficiency. The resulting biomass rivals highly productive tropical rainforests. Researchers measured carbon fixation rates in these mats. They found staggering volumes of new organic material. A single square meter produces kilograms of carbon. This continuous chemical harvest sustains massive animal populations. Giant tube worms depend entirely on this bacterial production. They lack a digestive system to process normal food. Instead, they host billions of these industrious microbes inside. The partnership exemplifies perfect biological symbiosis in darkness. Slowly, the raw chemical energy transforms into complex living tissue. This process sustains the entire deep ocean food web. Fact number 13. Hydrothermal vent chimneys exhibit astonishing vertical growth rates. Mineral structures can grow 30 centimeters in one day. This rapid accumulation outpaces any known geological formation. Stalactites in caves take centuries to grow an inch. Vent chimneys build themselves through constant mineral precipitation. Hot acidic fluid carries heavy concentrations of dissolved metals. The fluid hits cold seawater and immediately solidifies. Tiny mineral particles stack upon each other continuously. A small mound quickly becomes a towering spire. Some chimneys reach heights of 15 ocean meters. Their rapid growth makes them structurally fragile and unstable. Strong ocean currents can easily topple these delicate towers. Earthquakes frequently fracture the towering and delicate mineral formations. When a chimney falls, a new one begins immediately. The vent fluid simply redirects through the fresh rubble. Scientists once observed a chimney rebuild within a week. They returned to find a completely new geological landscape. This dynamic environment forces local organisms to constantly relocate. Marine life must constantly adapt to ever-shifting mineral structures. The silent construction never ceases in the dark waters. Fact number 14. The Lost City hydrothermal field is completely unique. Researchers discovered this strange environment in the year 2000. It sits on the Atlantis Massif underwater mountain. Unlike typical black smokers, these vents are highly alkaline. The fluid pH ranges from 9 to 11. Typical black smokers emit highly acidic mineral fluids. The Lost City chimneys are pure white calcium carbonate. They resemble massive ghostly towers in the deep ocean. The tallest structure stands 60 meters above the seafloor. Scientists named this towering formation the Poseidon Complex. The water here is cooler than typical volcanic vents. Temperatures range from 40 to 90 degrees Celsius. Heat comes from a chemical reaction called serpentinization. Cold seawater reacts directly with exposed deep mantle rock. This reaction produces vast quantities of hydrogen and methane. These gases support a completely distinct microbial ecosystem. The life forms here differ from black smoker ecosystems. Many scientists believe life began in similar alkaline environments. The gentle chemistry mimics conditions of the early Earth. Fact number 15. The Pompeii worm is an absolute marvel of adaptation. It thrives on the sides of active black smokers. These worms endure the highest temperatures of any animal. Their tail ends rest in 80 degrees Celsius water. Their heads protrude into much cooler 20-degree water. A 60-degree temperature gradient exists across their small bodies. The worms construct thin parchment-like tubes for shelter. They constantly secrete mucus to maintain their delicate tubes. A thick layer of symbiotic bacteria covers their backs. This bacterial fleece provides essential thermal insulation for them. The bacteria also process toxic heavy metals from vents. Scientists discovered these fascinating creatures in 1980. They named them after the famous buried Roman city. Ash-like mineral particles constantly rain down upon their tubes. The worms must continuously clear this heavy mineral debris. Without this effort, the falling minerals would bury them entirely. They retreat deep into their tubes when threatened. Their survival mechanisms remain a subject of intense study. Biology rarely functions at such extreme thermal limits. Fact number 16. Active hydrothermal vents possess surprisingly short geological lifespans. A single vent might remain active for merely decades. Magma chambers beneath the seafloor constantly shift and cool. Tectonic plates move away from the active spreading centers. This movement disconnects the vent from its heat source. Mineral deposits also slowly clog the internal plumbing systems. Fluid flow gradually weakens as the pipes narrow. Eventually, the hot mineral springs stop flowing entirely. The towering chimneys grow cold and completely silent. Without chemical energy, the vibrant ecosystem quickly collapses. Tube worms and clams die from starvation within months. Only empty white shells remain scattered across the basalt. Deep-sea scavengers consume the remaining organic material slowly. The dead chimneys slowly dissolve back into the ocean. However, new vents open nearby along the fault lines. Larvae from the dying vent drift through the darkness. They ride deep ocean currents seeking fresh hydrothermal plumes. This creates a continuous cycle of death and rebirth. The oasis moves, but the desert remains vast. Fact number 17. Hydrothermal vents act as natural deep-sea mining factories. The superheated fluids dissolve precious metals from crustal rocks. These metals concentrate heavily within the chimney structures. A single chimney contains vast amounts of valuable minerals. Copper, zinc, and silver precipitate into solid sulfide mounds. Some vents produce extraordinarily high concentrations of pure gold. The gold content exceeds many profitable terrestrial mining operations. Ancient hydrothermal deposits currently provide much of our copper. Millions of years ago, tectonic forces pushed them upward. These ancient seafloor deposits now sit on dry land. Geologists call them massive volcanogenic sulfide ore deposits. Cyprus holds famous copper mines formed by ancient vents. Modern companies now want to mine active ocean vents. They design massive robotic machines to harvest the seafloor. This proposed mining threatens fragile and unique biological communities. Scientists strongly advocate for protecting these rare ocean habitats. The ecological cost of mining remains completely unknown. We weigh precious metals against irreplaceable biological diversity. The silent deep holds riches beyond human imagination. Fact number 18. Yeti crabs are extraordinary farmers of the deep sea. Researchers discovered these pale crustaceans in 2005. They live near the Pacific-Antarctic Ridge hydrothermal vents. Their long arms feature dense coverings of pale bristles. These bristly hairs look exactly like thick white fur. The crabs use this fur to cultivate specialized bacteria. They position their hairy claws directly over the vents. The flowing methane and sulfide nourish the bacterial crops. The crabs slowly wave their arms through the fluid. This rhythmic motion ensures a steady flow of nutrients. Scientists call this behavior the Yeti crab dance. When the bacteria multiply, the crab harvests its crop. They use special mouth appendages to scrape the bristles. This agricultural strategy provides their entire food supply. They live in incredibly dense clusters around the vents. A single square meter can hold 600 crabs. They constantly jostle for the best thermal farming positions. The crabs are completely blind in the absolute darkness. They navigate this chaotic environment using chemical sensors alone. Fact number 19. Hydrothermal vents are not silent structures in the deep. They produce distinct and measurable low-frequency acoustic signatures. The high-pressure fluid creates sound as it escapes rapidly. Boiling fluids and trapped gas bubbles generate continuous noise. The mineral chimneys act like massive geological pipe organs. They resonate with deep acoustic vibrations through the water. Oceanographers use hydrophones to record these deep underwater sounds. The frequencies often fall below human hearing capabilities. Specialized software translates these vibrations into audible audio tracks. The resulting sound resembles a low, continuous, rumbling storm. Each vent field possesses a completely unique acoustic footprint. Changes in the sound indicate shifting underground magma pressures. Scientists monitor these acoustic changes to predict seafloor eruptions. Some researchers believe local animals use these sounds for navigation. Vent larvae might follow the noise to find new homes. Sound travels much farther than chemical signals underwater. The rumbling guides them through the vast dark ocean. It acts as a sonic lighthouse in the abyss. The deep ocean hums with constant geological activity. Fact number 20. Hydrothermal vents exist far beyond our own home planet. Saturn has a small, icy moon known as Enceladus. The Cassini spacecraft flew through plumes erupting from Enceladus. It detected microscopic silicon nanoparticles within the frozen spray. These specific particles only form under very precise conditions. They require liquid water temperatures above 90 degrees Celsius. They also require interactions with rocky planetary core materials. This discovery strongly indicates active hydrothermal vents on Enceladus. A massive liquid ocean hides beneath miles of ice. Tidal friction from Saturn generates the necessary internal heat. This heat drives the alien hydrothermal circulation system. The chemical conditions match early Earth vent systems perfectly. Hydrogen gas is abundant in the Moon's watery plumes. This hydrogen could serve as fuel for microbial life. Astrobiologists consider Enceladus a prime target for finding life. The dark alien ocean might harbor chemosynthetic bacterial ecosystems. Future space missions will carry advanced life detection instruments. They will search for organic molecules in the spray. Our deep oceans prepare us for exploring outer space. Fact number 21. The Pompeii worm thrives in extreme temperature gradients. This creature lives directly on black smoker chimneys. The worm is scientifically known as Alvin pompegiana. The worm builds thin tubes along the vent walls. Its tail rests in water reaching 80 degrees Celsius. Its fragile head extends into cooler ocean water. The water near its head is 22 degrees. This represents a temperature drop of 60 degrees. The distance between head and tail is mere centimeters. No other complex animal survives such a thermal gradient. A fleece of bacteria covers the worm's back. These microbes act as a protective thermal blanket. They also secrete enzymes that resist extreme heat. Scientists discovered this remarkable species in 1980. The worm grows to 13 centimeters in length. Its pale gray body looks like an alien organism. Red tentacle-like gills protrude from its fragile head. These gills absorb oxygen from the surrounding currents. The species remains a marvel of biological adaptation. Fact number 22. Vent fluids carry massive amounts of dissolved metals. Deep ocean water seeps into the fractured basalt crust. Magma heats this trapped water to extreme temperatures. The boiling fluid dissolves minerals from the surrounding rock. Copper, zinc, and gold become suspended in the liquid. The superheated fluid shoots back into the freezing ocean. Cold seawater causes the dissolved metals to instantly precipitate. Clouds of metal sulfides billow into the water. These heavy particles slowly drift down to the seafloor. Over thousands of years, massive metal deposits accumulate here. Some extinct vent sites contain millions of tons of ore. Mining companies study these deep oceanic mineral reserves. The concentration of gold is surprisingly high at vents. It often exceeds the yield of terrestrial gold mines. Extracting these metals presents immense modern technological challenges. The crushing pressure makes deep-sea mining incredibly difficult. Preserving the fragile vent ecosystems remains a primary concern. These metallic towers hold vast untapped geological wealth. Fact number 23. Black smoker chimneys have surprisingly short geological lifespans. These structures grow at an astonishingly rapid pace. Some chimneys grow 30 centimeters in a single day. Minerals constantly stack upon each other as fluid escapes. A chimney can reach 20 meters in just months. This extremely rapid growth creates severe structural instability. The tall mineral spires become top-heavy and quite fragile. Ocean currents push against the brittle rock towers. Eventually, the towering structures collapse under their own weight. A single chimney rarely lasts more than a few decades. When a spire falls, a new one immediately begins forming. The vent field is a landscape of constant destruction. It is also a place of continuous rebirth. Fallen chimneys create a dense layer of metallic rubble. This rubble provides a foundation for future mineral growth. Geologists map debris fields to understand vent history. The cycle of growth and collapse shapes the seafloor. This dynamic process continues endlessly in the dark abyss. Fact number 24. Chemosynthesis replaces photosynthesis in deep ocean vent ecosystems. Sunlight cannot penetrate to these extreme oceanic depths. Plants cannot survive in this absolute eternal darkness. Specialized bacteria form the base of the food chain. These microbes absorb toxic hydrogen sulfide from the vents. They use chemical energy to break apart sulfide molecules. This reaction produces pure sulfur and organic carbon. The bacteria essentially create food from toxic volcanic gases. Many vent animals consume these bacteria directly for nourishment. Other creatures host the bacteria inside their own bodies. This symbiotic relationship allows complex life to flourish here. Scientists first confirmed this biological process in 1977. It completely revolutionized our understanding of planetary biology. Life does not strictly require the sun to survive. Chemical energy from the Earth can sustain entire ecosystems. This discovery expanded the search parameters for extraterrestrial life. Moons with subsurface oceans might host similar chemosynthetic communities. The dark ocean floor holds secrets to life's origins. Fact number 25. The transatlantic geotraverse hydrothermal field is absolutely massive. Scientists usually refer to it simply as the TAG field. The field is located on the Mid-Atlantic Ridge. Researchers discovered this sprawling site in 1985. It rests at a depth of 3,600 meters. The TAG field is one of the largest vent systems known. The active mound measures 200 meters across. It stands nearly 50 meters above the surrounding seafloor. This structure consists entirely of precipitated metallic sulfides. The mound has been active for over 100,000 years. It experiences cycles of intense activity and dormancy. The current active phase began about 50 years ago. Black smokers cluster heavily near the center of the mound. They release fluids reaching 360 degrees Celsius. The surrounding area features older, extinct mineral deposits. Deep sea currents sweep across this underwater terrain. The TAG field provides data on long-term vent evolution. It remains a primary target for deep geological studies. Fact number 26. A unique species of blind shrimp dominates Atlantic vent sites. The scientific name of this creature is Rimicaris exoculator. These pale shrimp gather by the millions around black smokers. They completely lack traditional stalked eyes in adulthood. Normal eyes would be useless in the pitch-black depths. They possess a specialized light-sensing organ on their backs. This dorsal organ detects faint infrared thermal radiation. The superheated vent water emits a dim infrared glow. The shrimp use this sensor to navigate the thermal gradients. It prevents them from swimming into boiling vent fluids. If they swim too close, they will instantly cook. The shrimp graze on bacterial mats growing on the chimneys. They constantly scrape the rocks with specialized feeding appendages. Their bodies are packed tightly together in dense swarms. Sometimes thousands of shrimp occupy a single square meter. They move like a synchronized pale cloud in the darkness. This adaptation showcases the brilliant resilience of deep ocean life. Fact number 27. White smoker vents produce highly alkaline hydrothermal fluids. Black smokers typically emit highly acidic boiling water. White smokers operate under entirely different chemical conditions. Fluid from a white smoker is rich in calcium. It lacks the iron sulfides found in black smokers. This creates the milky white plume of these vents. The pH level of white smoker fluid is high. It often reaches a pH of 10 or even 11. This makes the water as alkaline as household ammonia. The temperatures are cooler than those of black smokers. White smoker fluids range from 40 to 90 degrees. These cooler environments support different types of microbes. Carbonate minerals precipitate to form pale chimney structures. These chimneys grow slower than their black counterparts. They form delicate spires that resemble pale stalagmites. The alkaline environment closely mirrors early Earth conditions. Many scientists believe life may have originated in such waters. These pale towers hold clues to the dawn of biology. Fact number 28. The Lost City hydrothermal field is completely unique. Researchers discovered this site in the year 2000. It sits on an underwater mountain called the Atlantis Massif. Magma does not drive the Lost City vent system. It is powered by a chemical reaction called serpentinization. Seawater reacts with exposed mantle rock called peridotite. This reaction generates massive amounts of natural heat. It produces high concentrations of hydrogen and methane gas. The chimneys are composed of pure white calcium carbonate. Some of these majestic towers reach 60 meters in height. They look like ancient ruined cathedrals in the deep sea. The fluid venting from the Lost City is highly alkaline. The site has been active for over 30,000 years. This longevity exceeds typical black smoker vent systems. The Lost City hosts a unique ecosystem of specialized microbes. It represents an entirely new type of deep-sea environment. Similar systems might exist on other rocky planets or moons. Fact number 29. Hydrothermal vents are teeming with diverse viral populations. Viruses are the most abundant biological entities in the ocean. Around deep-sea vents, their numbers are astronomically high. A single milliliter of vent fluid contains millions of viruses. These viruses primarily infect the local chemosynthetic bacteria. Extreme pressure and heat do not destroy these viruses. They have adapted perfectly to this hostile environment. When viruses infect bacteria, they alter the host's genetic code. This genetic exchange accelerates bacterial evolution at the vents. The viruses essentially drive the adaptation of the entire ecosystem. They control the bacterial population through constant infection cycles. When infected bacteria die, they release vital organic nutrients. This process feeds other microscopic organisms in the water. Scientists use deep-sea submersibles to collect viral samples. Studying them helps us understand viral resilience and transfer. These invisible entities shape the foundation of the vent food web. The deep sea remains a vast reservoir of unknown genetics. Fact number 30. Hydrothermal vents generate incredibly powerful acoustic signatures underwater. The deep ocean is rarely a completely silent place. As superheated fluid escapes the crust, it creates sound. The boiling water produces a continuous low-frequency rumble. It sounds like a distant, heavy freight train. Scientists use underwater microphones called hydrophones to listen. These hydrophones can detect vent noises from many miles away. Pitch and volume change based on the fluid's velocity. Larger black smokers produce deeper and louder acoustic tones. Sound waves travel efficiently through the dense, cold seawater. Researchers analyze these audio recordings to find new vent fields. The acoustic data reveals the intensity of the volcanic activity. Some marine animals might use these sounds for deep navigation. Predators could potentially track the noise to find feeding grounds. The mechanical roar of the earth echoes through the abyss. Listening to the seafloor provides a new way to explore. The song of the hydrothermal vents is haunting and continuous. Fact number 31. Hydrothermal vent chimneys grow at astonishingly rapid rates. Some structures expand by 30 centimeters every single day. Mineral deposits accumulate quickly in the freezing ocean water. Superheated fluids carry heavy dissolved metals from the crust. These metals precipitate immediately upon hitting the cold sea. A massive chimney named Godzilla grew 15 stories tall. It reached 45 meters before collapsing in 1996. The structure completely rebuilt itself within just 2 years. Scientists measured its new growth at incredible speeds. Such extremely rapid geological formation is rare on Earth. Most geological processes require thousands of years to manifest. Vent chimneys completely defy this standard geological timeline. They are dynamic structures constantly shifting in size. Deep ocean currents constantly erode their fragile mineral walls. Yet the relentless upward flow rebuilds them endlessly. This rapid cycle creates an ever-changing deep-sea landscape. The fluid flow rate determines the exact growth speed. Researchers observe the chimneys evolving visibly every single day. Fact number 32. The Lost City hydrothermal field operates differently than others. It does not rely on underlying volcanic magma chambers. Instead, it uses a deep chemical reaction called serpentinization. Seawater reacts directly with exposed mantle rock called peridotite. This chemical reaction generates its own internal heat. The resulting fluids are highly alkaline, not acidic. They reach a high pH of 9 to 11. The field produces tall, white calcium carbonate towers. Some of these delicate spires reach 60 meters high. Scientists discovered this unique field in the year 2000. It sits on the Atlantis Massif in the Atlantic. The fluid temperatures remain significantly lower in this area. They range from 40 to 90 degrees Celsius. Despite the lower heat, life still flourishes abundantly. Microbes consume hydrogen and methane produced by the rocks. This location shows life can exist without volcanic activity. It broadens our scientific search parameters for extraterrestrial life. Similar chemical reactions might occur on icy ocean moons. Fact number 33. Many black smoker fluids are incredibly acidic environments. Their pH levels often drop to 2.8. This acidity matches the strength of commercial vinegar. The low pH dissolves heavy metals from the crust. Iron, copper, and zinc become suspended in the liquid. These metals give black smokers their characteristic dark plumes. Most marine life would dissolve in such harsh conditions. Calcium carbonate shells cannot form in this acidic water. Yet specialized organisms have adapted to this extreme chemistry. They build protective outer layers using different chemical compounds. The acidity neutralizes quickly as it mixes with seawater. Ocean water maintains a slightly alkaline pH of 8. This mixing creates a steep chemical gradient near vents. Bacteria exploit this sharp gradient to harvest chemical energy. The acidic fluids alter the surrounding basaltic rocks. They leach away certain minerals and deposit others. This constant chemical exchange shapes the ocean floor chemistry. It also influences the global balance of marine elements. Fact number 34. Hydrothermal vents might be the birthplace of all life. Alkaline vents create millions of microscopic iron sulfide bubbles. These mineral bubbles resemble the structure of organic cells. They contain tiny compartments separated by thin mineral walls. These walls act like primitive biological cell membranes. They trap organic molecules inside their microscopic chambers. A natural proton gradient exists across these mineral walls. This gradient mirrors the energy system of living cells. Early chemical reactions could have occurred inside these pores. The stable environment protected fragile new organic compounds. Scientists currently call this the iron-sulfur world hypothesis. Researchers first proposed it in the 1980s. The theory suggests life did not begin in soup. Instead, it started within the solid matrix of vent rocks. Eventually, these primitive systems developed their own lipid membranes. They detached from the rock and floated into the ocean. This theory connects geology directly to early biology. It remains a leading explanation for life's mysterious origins. Fact number 35. The Pompeii worm endures incredibly extreme temperature gradients daily. It lives in tubes attached directly to black smokers. Its sensitive tail end rests near boiling water. Temperatures at its tail reach 80 degrees Celsius. However, the worm's head extends into the cooler ocean. The ocean water near its head is only 22 degrees. This creates a massive temperature drop across its body. A 60-degree difference exists over just 10 centimeters. No other complex animal survives such a thermal gradient. The worm secretes a special mucus from its back. This mucus feeds a thick blanket of symbiotic bacteria. The bacteria act as a biological insulation layer. They protect the worm from the intense vent heat. Scientists discovered this remarkable creature in 1980. They named it after the famous volcanic Roman city. The worm's enzymes function perfectly at incredibly high temperatures. Researchers now study these enzymes for various industrial applications. They could improve heat-resistant detergents and chemical processes. Fact number 36. Some vent shrimp possess a unique visual organ. The Rimicaris exoculator shrimp lacks normal stalked eyes. It has a large light-sensing organ on its back. This dorsal organ contains highly specialized light-detecting cells. It connects directly to the shrimp's central brain. The deep ocean environment lacks all natural sunlight. However, hydrothermal vents emit a very faint thermal glow. The shrimp use this dorsal organ to see the vents. It helps them locate the nutrient-rich black smokers. More importantly, it prevents them from getting cooked. The organ detects the dangerous heat radiating from the chimneys. Thousands of shrimp swarm around the warm fluids. They graze on thick mats of chemosynthetic bacteria. If they swim too close, the boiling water kills them. Their specialized back eye acts as a thermal warning system. Scientists discovered this adaptation in the late 1980s. It proved that vision exists even in total darkness. The shrimp navigate their hazardous world using invisible light. Fact number 37. Hydrothermal vents produce their own faint, ghostly light. This phenomenon is invisible to the human eye. Scientists first detected it using highly sensitive digital cameras. The glow is not caused by standard thermal radiation. Instead, it comes from a process called crystalloluminescence. Minerals crystallize rapidly as hot fluids meet cold seawater. This rapid crystal formation releases tiny bursts of energy. The energy manifests as a very dim optical glow. Another source of light is sonoluminescence from collapsing bubbles. The intense pressure causes microscopic bubbles to implode violently. These violent implosions generate brief flashes of underwater light. The emitted light spectrum peaks in the infrared. Some specific wavelengths extend into the visible light spectrum. Deep-sea creatures might use this light for navigation. It provides a beacon in the pitch-black ocean. Researchers mapped this faint illumination using specialized submersibles. The famous Alvin submersible captured the first clear images. It reveals a hidden layer of energy in the deep. Fact number 38. Hydrothermal vents accumulate significant amounts of precious metals. Gold is heavily concentrated in certain seafloor massive sulfides. The superheated vent fluids dissolve gold from deep volcanic rocks. They carry the dissolved gold upward toward the ocean floor. When the fluid hits cold water, the gold precipitates out. It settles into the rocky structure of the vent chimneys. Some deposits contain up to 20 parts per million gold. This concentration is much higher than typical land-based mines. Silver and copper also accumulate in massive quantities here. Mining companies are currently targeting these deep-sea deposits. They hope to extract these metals for modern electronics. However, deep-sea mining poses severe environmental risks. It could destroy fragile and unique vent ecosystems forever. Scientists urge caution regarding commercial extraction of these minerals. The vents take thousands of years to build these deposits. A single mining operation could erase them in days. International authorities are currently debating strict deep-sea regulations. Fact number 39. Yeti crabs farm their own food on their bodies. These pale crustaceans have long claws covered in dense hair. The specialized hairs are called setae by marine biologists. These hairs trap highly toxic chemicals from the vent fluids. The crabs use these chemicals to cultivate symbiotic bacteria. Thick mats of bacteria grow rapidly on their hairy arms. The crabs continuously wave their arms over the vent streams. This rhythmic motion provides fresh nutrients to the bacterial crop. When hungry, The crab simply scrapes the bacteria into its mouth. It uses a specialized mouth appendage for this exact purpose. Scientists discovered the first Yeti crab in 2005. They found it near the Pacific-Antarctic ridge in the ocean. The crab is completely blind and lacks any visual organs. It relies entirely on chemical sensors to navigate the vents. This unique farming behavior ensures a steady food supply. It allows the crab to thrive in a barren wasteland. Fact number 40. The Endeavour hydrothermal vents form a massive underwater field. This region became Canada's first official marine protected area. The designation occurred in 2003. It sits 250 kilometers southwest of Vancouver. The field lies 2,200 meters underwater. It features the tallest chimneys in the world. Many structures rise 30 meters from the seafloor. The area hosts unique species found nowhere else on Earth. 12 distinct species are entirely endemic to this specific ridge. The status prevents commercial deep-sea mining operations. It also restricts bottom trawling and destructive fishing practices. Only approved scientific research is permitted in this zone. Researchers use acoustic sensors to monitor the vent activity constantly. They track the flow of superheated water and seismic events. This protection preserves a pristine laboratory for future scientific generations. It serves as a model for international ocean conservation efforts. Protecting these habitats ensures the survival of rare deep-sea life. Fact number 41 reveals a shocking energy secret. Hydrothermal vent chimneys function as natural geological batteries. The walls of black smokers constantly conduct electricity. Iron and copper sulfides form the tall chimney structures. These minerals readily transfer electrons across the vent wall. The inner hydrothermal fluid is highly rich in hydrogen. The surrounding deep seawater contains abundant dissolved oxygen. This chemical imbalance creates a measurable electrical gradient. Researchers measured this current in 2010. A single chimney can generate up to 1 volt. This voltage closely mirrors a standard commercial alkaline battery. Specialized deep microbes actually harvest this electrical energy directly. They attach themselves to the conductive mineral surfaces. Electrons flow from the deep earth into their cells. This biological process bypasses traditional chemical consumption entirely. It represents a completely unique form of biological metabolism. Scientists call this phenomenon direct interspecies electron transfer. The discovery expanded our definition of life-sustaining energy. This hidden power grid operates continuously in the abyss. Life literally plugs into the rocks for raw power. Fact number 42 explores a strange white city. The Lost City hydrothermal field features unique alkaline chemistry. Explorers discovered this strange site in December 2000. It rests heavily on the submerged Atlantis Massif mountain. This location sits slightly off the mid-Atlantic ridge. The tall chimneys here consist entirely of calcium carbonate. They appear stark white against the dark ocean background. Some towers reach 60 meters in total height. The tallest structure is formally named the Poseidon Pillar. The circulating vent fluids here are highly alkaline. Their chemical pH levels range from 9 to 11. The emitted fluid temperatures remain relatively low overall. They rarely exceed 90 degrees Celsius in temperature. This differs greatly from traditional black smoke vents. The heat originates from a process called serpentinization. Seawater reacts chemically with exposed deep mantle rocks. This reaction releases heat and abundant hydrogen gas. The local environment supports remarkably dense microbial communities. It lacks the large tubeworms found at other sites. Scientists study this site to understand early Earth conditions. Fact number 43 introduces an armored metallic snail. The scalyfoot snail builds its shell with iron armor. Biologists discovered this gastropod in 2001. It lives exclusively in the Indian Ocean vent fields. The water depth exceeds 2,400 meters. This snail incorporates iron sulfides into its dermal scales. It is the only animal using iron this way. The iron minerals include both graphite and pyrite. The mineral graphite makes the snail naturally magnetic. Magnets can easily pick up these deep-sea creatures. The iron armor protects them from predatory crabs. It also shields them from toxic vent fluids. The snail houses symbiotic bacteria in a specialized gland. These bacteria produce all necessary food for the host. The snail has a massive heart to supply oxygen. Its heart comprises 4% of its body volume. Mining threats recently endangered this highly unique species. Conservationists officially listed it as an endangered species. It became the first species threatened by deep-sea mining. Evolution forged a creature of living metal here. Fact number 44 explains global ocean chemical cycles. Hydrothermal vents constantly regulate global deep ocean chemistry. They act as massive underwater chemical processing plants. The entire ocean cycles through these deep vents. This circulation cycle takes roughly 10 million years. Seawater seeps down through cracks in the crust. Intense geological heat strips magnesium from the water. The surrounding rock completely absorbs this dissolved magnesium. This process removes excess magnesium from the ocean. Simultaneously, hot fluids dissolve iron from the crust. The vents then eject this iron into the sea. Phytoplankton at the ocean's surface desperately need this iron. Upwelling ocean currents slowly carry the vent iron upward. This fertilizes the upper ocean and supports marine life. Without vents, the oceans would become toxic with magnesium. The surface waters would also lack essential iron nutrients. The deep earth maintains a delicate marine chemical balance. Vents act as the vital valves for this system. They connect the molten mantle to the biological biosphere. Every drop of seawater eventually visits the fiery depths. Fact number 45 focuses on pale white smokers. White smokers are a distinct class of vents. They differ significantly from their black smoker counterparts. White smokers constantly emit lighter-colored chemical mineral plumes. These plumes contain high levels of barium and calcium. They also carry many abundant dissolved silicon compounds. Fluid temperatures are generally cooler at these sites. They range from 200 to 300 degrees. Black smokers usually exceed 350 degrees. Lighter minerals precipitate as the fluid hits cold seawater. This creates the illusion of billowing white smoke. The chimneys are often light gray or pinkish. They form further away from the central heat source. White smokers appear on the periphery of vent fields. They host different biological communities than black smokers. Certain species of barnacles prefer these cooler white vents. The pale mineral deposits grow at a slower rate. These structures can last longer than hotter black chimneys. The pale towers stand like ghosts in the abyss. Life adapts perfectly to these gentler hydrothermal flows. Fact number 46 looks into the deep solar system. Hydrothermal vents likely exist beyond our home planet. Scientists found evidence of them on Saturn's moon Enceladus. The Cassini spacecraft flew through plumes of water vapor. These huge plumes erupted from the icy surface. Instruments analyzed the chemical composition of this spray. They detected microscopic silica particles in the ejected water. These particles only form under precise physical conditions. Hot alkaline water must interact with rocky core materials. The water temperature must exceed 90 degrees Celsius. This matches the conditions of Earth's hydrothermal vents. Enceladus possesses a global ocean beneath its icy crust. Tidal friction from Saturn generates massive internal heat. This heat warms the rocky core of the Moon. Water circulates through the core and emerges as vents. The presence of molecular hydrogen further supports this theory. Hydrogen serves as a food source for vent microbes. This makes Enceladus a prime target for astrobiology. Alien life might thrive around these extraterrestrial vents. We may not be alone in the dark universe. Fact number 47 features a heat-loving marine worm. The Pompeii worm holds a remarkable temperature record. It ranks among the most heat-tolerant animals on Earth. Scientists discovered this fascinating species in 1980. It lives exclusively on the sides of black smokers. The worm builds a papery tube on the chimney. Its tail rests near the hot vent fluid. The tail experiences temperatures up to 80 degrees Celsius. Its head remains in the cooler surrounding seawater. The head temperature hovers around 22 degrees Celsius. This creates a massive temperature gradient across its body. The gradient spans 60 degrees over just 13 centimeters. Thick symbiotic bacteria cover the worm's back entirely. These bacteria look like a pale, fuzzy fleece. The fleece insulates the worm from the searing heat. It also detoxifies heavy metals in the vent fluid. The worm secretes sugary mucus to feed these microbes. They share a perfect, mutually beneficial biological relationship. The Pompeii worm thrives where most creatures would perish. Nature constantly pushes the boundaries of biological survival. Fact number 48 highlights a modern human threat. Hydrothermal vents face a looming threat from industry. Deep-sea mining companies actively target these mineral-rich habitats. Black smokers accumulate massive deposits of valuable metals. These include copper, zinc, gold, and rare earth elements. The minerals form massive sulfide deposits on the seafloor. Modern technology allows extraction from these extreme depths. Mining machines would physically crush the vent chimneys. This process would instantly destroy the local ecosystems. Sediment plumes would choke filter-feeding organisms miles away. Noise pollution would disrupt marine mammal communication networks. Vent species are highly specialized and geographically isolated. Destroying a single field could cause entire species extinctions. The International Seabed Authority currently regulates these mining activities. They are drafting exploitation codes for the international seabed. Conservationists argue for strict protection of all vent sites. The ecological value far outweighs the short-term mineral gains. Once destroyed, a vent ecosystem might never fully recover. The deep ocean remains a fragile, interconnected biological web. The future of these unique habitats remains highly uncertain. Fact number 49 details the lifespan of vents. Individual hydrothermal vents possess surprisingly short geological lifespans. A typical black smoker remains active for only decades. Some larger fields might persist for a few centuries. The tectonic plates constantly shift beneath the ocean floor. This movement alters the plumbing of the crust. Magma chambers cool down or migrate to new locations. Earthquakes frequently collapse the narrow subterranean fluid channels. When the heat source vanishes, the vent quickly dies. The billowing mineral smoke slows to a mere trickle. Eventually, the flow of hot fluid stops entirely. The biological community faces immediate and catastrophic starvation. The vibrant tube worms and crawling crabs slowly die off. The chimneys remain standing like abandoned, silent monuments. Deep-sea currents gradually erode the brittle sulfide structures. Scavengers consume the last traces of organic matter. The site returns to the barren abyssal plain. New vents will open miles away along the ridge. The dark ocean floor reclaims its quiet, cold state. Microbes drift away to seek new sources of energy. Fact number 50 involves advanced robotic deep exploration. Scientists use autonomous underwater vehicles to map vent fields. These robots are commonly known by the acronym AUVs. They operate without a physical tether to the surface. Researchers program them with precise grid search patterns. The AUVs dive deep into the ocean abyss. They glide silently above the rugged seafloor terrain. Sensors constantly sniff the water for chemical anomalies. They detect tiny changes in temperature and water clarity. A spike in dissolved methane indicates a nearby vent. The robots also measure the water's oxidation reduction potential. This reveals the presence of fresh hydrothermal emissions. When an AUV detects a plume, it turns. It traces the chemical trail to its source. High-resolution sonar maps the physical structure of the chimneys. Cameras capture thousands of overlapping images of the site. The vehicle returns to the surface after 24 hours. Scientists download the data to create precise three-dimensional maps. This technology revolutionized deep-sea exploration in recent years. The robotic explorers work tirelessly in the crushing darkness. Fact number 51. Vent chimneys can collapse and rebuild with astonishing speed. These massive mineral structures are highly unstable underwater. Seismic activity frequently shakes the tectonic plate boundaries. Deep earthquakes easily topple the towering sulfide spires. Yet the natural rebuilding process begins almost immediately. Superheated fluids continue pouring from the ruptured seafloor. Minerals precipitate the moment they hit cold water. A new chimney can grow 30 centimeters per day. In a single year, a tower might reach 9 meters. Scientists documented this rapid growth in 1991. They observed a collapsed vent on the East Pacific rise. Returning 11 months later revealed entirely new formations. Some new chimneys had already grown 15 meters tall. This relentless cycle of destruction and creation never stops. The shifting crust constantly reshapes the deep ocean landscape. Microbial colonies quickly colonize these fresh mineral surfaces. Life adapts to the perpetual physical turnover of its habitat. This dynamic environment demands extreme resilience from local species. The seafloor remains in a state of eternal flux. Fact number 52. Hydrothermal fluids carry high concentrations of rare earth elements. These metals are crucial for modern technological applications. Neodymium and yttrium dissolve in the superheated acidic water. Deep crustal rocks release these elements under extreme heat. The vent fluids transport them upward toward the ocean floor. Upon contacting cold seawater, the metals precipitate rapidly. They become trapped within the growing sulfide chimneys. Some vent deposits contain significant amounts of gold and silver. Copper concentrations can exceed those found in terrestrial mines. This mineral wealth has attracted commercial mining interests. Companies plan to harvest these dormant sulfide deposits. The process involves lowering massive robotic cutters to the seabed. Machines would grind the chimneys into a fine slurry. Pipes would pump this heavy mixture to surface vessels. Ecologists worry about the environmental impact of such operations. Mining could destroy fragile ecosystems in a matter of hours. Thick sediment plumes might smother neighboring vent communities. International authorities currently regulate these deep ocean mining proposals. The balance between resource extraction and preservation remains delicate. Fact number 53. Hydrothermal vents actively regulate global ocean water chemistry. Scientists once thought rivers were the sole chemical source. They believed rivers dictated the ocean's mineral composition. Vent discoveries in the late 70s changed this paradigm entirely. We now know the entire ocean cycles through the crust. This massive filtration process takes about 10 million years. Seawater seeps down through deep cracks in the basalt. The intense heat alters the water's chemical structure completely. Magnesium drops out of the water and enters the rock. This removal prevents the oceans from becoming too magnesium-rich. Simultaneously, the water absorbs iron and manganese from the crust. The vents then pump these new elements back out. This chemical exchange maintains the delicate balance of seawater. Without vents, the ocean's composition would drastically shift. Marine life depends on this steady chemical buffering system. The vents act as a planetary-scale water purifier. They ensure trace metals remain available for microscopic plankton. This deep oceanic plumbing system sustains the entire biosphere. Our planet's surface chemistry relies on these dark abyssal springs. Fact number 54. Fossilized hydrothermal vents exist high above modern sea level. Tectonic forces occasionally push sections of seafloor onto continents. Geologists call these displaced oceanic rock sequences archaeolites. One famous example lies in the Troodos Mountains of Cyprus. These ancient vents formed 90 million years ago. Dinosaurs walked the earth while these chimneys expelled black smoke. The Cyprus deposits provided early clues about vent formation. Miners extracted copper from these mountains for thousands of years. Ancient Romans used this very ore for their bronze weapons. They never knew the metal came from a deep ocean. This geological uplift took millions of years to complete. Scientists eventually recognized the distinct mineral signatures in the rocks. The fossilized chimneys perfectly match modern seafloor structures. Similar ancient vent formations exist in Oman and California. Some terrestrial deposits date back over 3 billion years. These rocky records allow researchers to study ancient ocean chemistry. They reveal how vent fluids interacted with primordial seawater. Studying them requires only a hammer instead of a submarine. The mountains hold the frozen memory of a boiling sea. Fact number 55. Vent fluid temperatures fluctuate in rhythm with ocean tides. The gravitational pull of the Moon affects the deep seafloor. Tidal forces physically squeeze and stretch the oceanic crust. This subtle movement alters the pressure within subsurface plumbing. During high tide, the weight of the water column increases. This added pressure restricts the flow of ascending hot fluids. The water spends more time absorbing heat from the magma. Consequently, the exiting fluid temperature rises slightly during high tide. Low tide reduces the pressure on the fractured bedrock. The hydrothermal fluids flow outward at a faster rate. They spend less time heating up deep within the crust. This causes the vent temperatures to drop by several degrees. These thermal cycles occur twice every 24 hours. Deep-sea organisms sense these subtle temperature shifts. Some species synchronize their feeding behaviors with the tidal rhythm. Even at extreme depths, the Moon exerts its quiet influence. The entire hydrothermal system pulses like a giant beating heart. This invisible connection links the abyssal plane to the cosmos. Fact number 56. The Lost City vent field differs entirely from black smokers. Researchers discovered this unique site in the year 2000. It sits on an underwater mountain in the Atlantic Ocean. The chimneys here do not emit dark, metal-rich smoke. Instead, they form towering white spires of calcium carbonate. Some of these pale structures reach 60 meters in height. The Lost City does not rely on underlying magma chambers. The heat comes from a chemical reaction called serpentinization. Seawater reacts directly with exposed mantle rocks called peridotite. This chemical process releases heat and highly alkaline fluids. The fluid pH can reach 11, similar to household ammonia. Temperatures here are much lower, rarely exceeding 90 degrees Celsius. The ecosystem lacks the giant tube worms found elsewhere. Instead, dense microbial biofilms coat the porous limestone spires. These microbes consume hydrogen gas and methane for energy. Snails and tiny crustaceans graze slowly on the bacterial mats. The site has remained continuously active for 30,000 years. This longevity far exceeds the lifespan of typical volcanic vents. Fact number 57. Vent ecosystems rely on a highly toxic chemical compound. Hydrogen sulfide gas smells strongly of rotting eggs. This chemical is normally lethal to most known marine life. It binds to blood proteins and halts cellular respiration completely. Yet deep-sea vent communities require this deadly gas. Specialized bacteria have evolved to consume the toxic sulfide. They use it to power the synthesis of organic carbon. This process is known in biology as chemosynthesis. Larger animals harbor these sulfide-eating bacteria inside their bodies. The host creatures must carefully manage the internal toxicity levels. Giant tube worms produce a unique form of hemoglobin. This specialized blood protein binds tightly to the free sulfide. It transports the toxic molecules safely to the symbiotic bacteria. The bacteria convert the poison into nourishing sugars. This evolutionary adaptation transformed a deadly environment into an oasis. Toxicity becomes the very foundation of the local food web. Without the lethal sulfide, the entire vent ecosystem would starve. Nature finds a way to utilize even the harshest substances. Life thrives in these incredibly hostile and unlikely places. Fact number 58. Hydrothermal vents may represent the birthplace of all earthly life. Scientists proposed this origin theory based on alkaline vent chemistry. Early Earth possessed a highly acidic and iron-rich ocean. Alkaline vents released warm, mineral-rich fluids into this ancient sea. The mixing of these fluids created natural proton gradients. These microscopic energy gradients mimic cellular energy production perfectly. Porous vent rocks provided tiny compartments for early chemical reactions. These tiny mineral pores acted as the first protective cell walls. Inside these chambers, simple molecules concentrated and combined over time. Amino acids and primitive proteins slowly assembled in the dark. This process required no sunlight or atmospheric oxygen to function. Researchers estimate this occurred around 3.8 billion years ago. The theory challenges the traditional idea of a sunlit primordial soup. It suggests life began in the crushing depths of the abyss. Modern microbes at the lost city share traits with these ancestors. Their genetic code points back to a hot, dark origin. We might all be distant descendants of a deep ocean chimney. The deep sea holds the ultimate secret of our genesis. Fact number 59. Vent shrimp lack normal eyes but can still see light. The species Rimicaris exoculator swarms around Atlantic black smokers. Thousands of these pale shrimp crowd the boiling chimney walls. Adults completely lack the eye stalks found on shallow water shrimp. Evolution erased their traditional vision in the pitch-black depths. However, they possess a highly specialized light-sensing organ. A large reflective patch covers the back of their heads. This dorsal organ contains light-sensitive pigments called rhodopsin. It cannot form distinct images of the surrounding environment. Instead, it detects faint thermal radiation emitted by the vents. The superheated water glows slightly in the near-infrared spectrum. This invisible glow guides the shrimp toward the nutrient-rich fluids. It also warns them if they swim too close to the boiling water. The sensory patch prevents the shrimp from being cooked alive. Scientists discovered this unique visual adaptation in the late 80s. It remains one of the most remarkable evolutionary traits known. The shrimp navigate their hazardous world using invisible heat signatures. They thrive on the very edge of absolute thermal destruction. Their survival depends entirely on this strange dorsal eye. Fact number 60. Active hydrothermal vents exist hidden beneath thick Arctic ice. The Gackle Ridge runs beneath the frozen Arctic Ocean surface. It represents the slowest spreading tectonic plate boundary on Earth. Scientists initially doubted vents could form in this sluggish region. They believed the magma supply was simply too low. Explorations in 2001 proved these early assumptions wrong. Sensors detected massive chemical plumes trapped beneath the sea ice. In 2014, researchers finally photographed the Aurora vent field. It sits 4,000 meters deep in freezing polar waters. The contrast between the boiling vents and icy surface is extreme. Thick ice prevents standard research vessels from accessing the site easily. Scientists must deploy autonomous submarines to navigate the dark waters. The Arctic vents host entirely unknown species of marine life. These isolated creatures cannot migrate to other global ridge systems. Ocean currents trap their larvae within the enclosed Arctic basin. Studying these icy vents helps plan future space exploration missions. Moons like Europa hide similar oceans beneath thick frozen crusts. The Arctic seafloor offers a perfect testing ground for alien life. Fact number 61 examines extreme vent fluid salinity. The salinity near hydrothermal vents varies quite dramatically. It rarely matches the normal seawater found above. Extreme deep ocean pressure alters basic water properties. Intense geothermal heat causes a massive phase separation. The rising fluid splits into two distinct parts. One part becomes a very low salinity water vapor. The other section forms a dense high salinity brine. This resulting brine is incredibly heavy and dense. It slowly pools in hidden ocean crust crevices. The lighter vapor rises quickly toward the surface. Salinity levels can be double that of seawater. Sometimes the salinity drops to almost absolute zero. Scientists measure this using specialized deep conductivity sensors. They first recorded these extremes in 1991. The Juan de Fuca ridge showed massive variations. This physical process affects local mineral deposition rates. The exact salt content dictates overall fluid buoyancy. These heavy brines move very slowly deep underwater. The low salinity fluids jet upward rapidly into seawater. These fluid differences shape the entire vent ecosystem. Drastic salinity shifts can happen in mere hours. Fact number 62 details a vanished hydrothermal vent. The famous Rose Garden vent disappeared completely underwater. Researchers first discovered this site in 1979. It sat quietly along the Galapagos Rift Zone. Thousands of giant red tube worms covered the area. The site looked exactly like a blooming flower bed. Scientists returned to the exact spot in 2002. Instead, they found only a fresh basalt rock surface. A recent volcanic eruption had completely paved the seafloor. The entire Rose Garden was buried deep under lava. Millions of living organisms perished during the volcanic event. This proved that vent ecosystems are highly fragile environments. They exist entirely at the mercy of tectonic forces. A brand new hydrothermal vent soon formed nearby. Researchers officially named this new biological site Rosebud. Life quickly began to colonize the freshly cooled rock. The endless cycle of destruction and rebirth continued naturally. Volcanic events erase biological history in just a few days. Yet the deep sea remains an incredibly resilient place. The beautiful Rose Garden remains a legendary scientific memory. Fact number 63 explores deep sea agricultural practices. Yeti crabs actually farm their own bacterial food supply. Scientists first discovered these creatures in 2005. They live peacefully near the Pacific Antarctic Ridge System. These pale crabs have incredibly hairy white front arms. The dense hairs are scientifically known as biological setae. They look exactly like pale fur waving underwater. The crabs slowly wave their arms over vent fluids. They are actively cultivating colonies of chemoautotrophic bacteria. The bacteria grow incredibly thick on the crab hairs. The crabs then harvest these microbes for daily nourishment. They use specialized mouth parts to scrape them off. It represents a unique form of deep-sea agriculture. Yeti crabs live in very dense seafloor communities. Up to 600 crabs share 1 square meter. Their official Latin scientific name is Kiwa hirsuta. They rely entirely on touch and chemical water sensors. Their farming technique ensures a perfectly steady food supply. This brilliant adaptation allows them to thrive in darkness. Fact number 64 reveals natural underwater electrical generators. Hydrothermal chimneys act as natural deep-sea electrical generators. The mineral vent walls separate very different chemical fluids. Inside the chimney sits a hot acidic water fluid. Outside the chimney flows cold alkaline ocean seawater. This stark contrast creates a natural chemical energy gradient. Iron and sulfur minerals form the thick chimney wall. These specific minerals are highly conductive natural earth materials. Tiny electrons flow across the porous mineral rock barrier. This steady movement generates a tiny electrical current underwater. Scientists carefully measured this exact voltage in 2010. A single mineral chimney produces nearly 1 full volt. Deep-sea microbes actually use this natural electricity for survival. They harvest electrons directly from the conductive rock surface. This amazing process is called extracellular electron transfer. It represents a completely different biological energy source. Life here feeds on pure electrical currents flowing endlessly. The dark ocean floor functions like a giant battery. These natural fuel cells operate constantly without ever stopping. They never run out of essential chemical fuel supplies. Fact number 65 explains the hidden deep carbon cycle. Hydrothermal vent systems heavily influence the global carbon cycle. Deep-sea microbes consume vast amounts of dissolved carbon dioxide. They pull this invisible gas from the surrounding water. The bacteria convert it into solid organic carbon materials. This vital process happens entirely without any warm sunlight. It is driven purely by chemical energy from the Earth. Researchers estimate vents process millions of tons annually. This biological pump traps excess carbon in the deep ocean. Their carbon-rich bodies become buried deep in the sediment. It acts as a completely natural ocean climate regulator. Some carbon slowly turns into solid limestone rock formations. This effectively locks the element away for millions of years. Vent chimneys also release some natural carbon dioxide gas. However, the thick microbial mats consume most of it quickly. The delicate balance of this underwater cycle is crucial. Scientists study this exchange using advanced mass spectrometers. They carefully analyze carbon isotopes in the warm vent fluid. Fact number 66 highlights the rapid growth of tube worms. Giant deep-sea tube worms grow at remarkably fast rates. The official scientific name for them is Rifsha pachyptela. These strange creatures lack both a mouth and a stomach. Instead, they rely entirely on internal symbiotic bacteria populations. These worms live closely near Pacific Ocean hydrothermal vents. They can grow up to 85 centimeters every single year. This makes them the fastest growing marine invertebrates on Earth. A single adult worm can reach 2 meters in length. They achieve this massive size in just under 3 years. Most deep-sea creatures grow very slowly due to freezing temperatures. The extreme cold usually limits their normal metabolic rates. But the warm vent fluids greatly accelerate biological processes. The worms absorb hydrogen sulfide through their bright red plumes. Their blood contains highly specialized hemoglobin transport molecules. This unique blood transports toxic chemicals safely inside their bodies. The internal bacteria turn these harsh chemicals into usable food. They quickly dominate newly formed hydrothermal vent ecosystems. Their long white protective tubes are made of tough chitin. Fact number 67 explores the deepest known hydrothermal vents. The BB vent field is an incredibly deep underwater site. It sits quietly along the remote mid-Cayman rise spreading center. The maximum depth reaches 4,960 meters. Scientists finally discovered this hidden site in 2010. They used a robotic submarine called AutoSub 60,000. The crushing water pressure here is nearly 500 atmospheres. Water boils at over 400 degrees Celsius down here. The BB field features massive underwater sulfide mineral mounds. Some chimney structures tower 20 meters above the dark seafloor. The expelled vent fluids are extremely rich in dissolved copper. Instead, dense swarms of blind pale shrimp dominate the area. The shrimp have special light-sensing organs on their upper backs. These organs detect faint infrared radiation emitted from the vents. The field is named after the famous explorer William Beebe. It represents a highly unique geological setting for marine biologists. This slow spreading creates extremely deep and persistent rock fractures. Fact number 68 examines the mysterious origin of earthly life. Iron sulfide bubbles may have started the first life on Earth. Early ancient oceans were highly acidic and full of iron. Hydrothermal fluids were highly alkaline and extremely rich in sulfur. When these two fluids met, they formed solid mineral precipitates. This reaction created millions of tiny hollow mineral rock bubbles. Scientists call these porous structures natural iron sulfide biological incubators. The tiny bubbles acted exactly like primitive biological cell walls. They safely trapped complex organic molecules inside their mineral chambers. The mineral walls naturally concentrated these vital chemical building blocks. A natural proton gradient formed across the thin bubble shell. This gradient provided the steady energy needed for chemical reactions. Researchers first proposed this fascinating theory in 1989. They form quite naturally under simulated deep-sea vent conditions. Complex genetic material could have evolved within these tiny chambers. This strongly suggests life began in the dark ocean depths. The vents provided endless geothermal heat and vital chemical fuel. Fact number 69 discusses valuable minerals hidden in the deep. Hydrothermal vent deposits contain high levels of rare earth elements. These valuable elements include metals like yttrium and heavy lanthanum. They are crucial for modern electronics and advanced green technology. Hydrothermal fluids leach these specific metals from deep crustal rocks. The extreme underground heat dissolves the rare elements quite easily. As the fluid hits cold seawater, the heavy minerals precipitate. They fall silently like dark snow onto the surrounding seafloor. Over millennia, massive sulfide mineral deposits slowly accumulate underwater. Some ancient deposits contain thousands of tons of rare metals. Geologists carefully map these areas using sonar and magnetic sensors. The overall concentration of rare earths is surprisingly very high. A single vent field can cover several square kilometers easily. Commercial mining companies are closely monitoring these deep-sea resources. The industrial mining process could destroy fragile vent biological ecosystems. The resulting sediment plumes might choke marine life for miles. Fact number 70 reveals the hidden sounds of hydrothermal vents. Scientists actively listen to hydrothermal vents using deep underwater hydrophones. These sensitive underwater microphones record massive deep ocean acoustic soundscapes. Hydrothermal vents are actually quite noisy and chaotic physical environments. The rushing hot fluids create a continuous low-frequency underwater rumble. Boiling water pockets generate very distinct and sharp acoustic signatures. Researchers deploy large hydrophone arrays near active ocean ridge systems. They can easily detect volcanic eruptions from hundreds of miles away. In 1998, an acoustic array recorded a massive event. The axial seamount volcano erupted violently deep underwater that year. The hydrophones captured the exact sound of lava hitting seawater. These crucial recordings help scientists predict future hydrothermal vent activity. They carefully track the movement of magma beneath the crust. The acoustic data reveals the hidden geological dynamics of the seafloor. Sound waves travel incredibly well through freezing deep ocean water. The hydrophones operate continuously for many years at a time. They run silently on long-lasting specialized lithium battery power packs. This provides a constant auditory window into the dark abyss. Fact number 71. Hydrothermal vents may explain the origin of cellular membranes. Early Earth oceans were hot and highly acidic. Alkaline vent fluids mixed with this acidic seawater. This mixing created natural proton gradients inside rock pores. These tiny pores acted like primitive cell walls. Minerals formed natural compartments for early chemical reactions. Iron and sulfur catalyzed the formation of organic molecules. Over millions of years, lipids began to accumulate. These lipids eventually formed the first true biological membranes. Scientists recreated these conditions in laboratory settings recently. The experiment occurred in 2019. Researchers observed membrane-like structures forming spontaneously in water. This discovery shifted our understanding of early biology. Life did not need sunlight to build cell walls. It only required the steady chemical energy of vents. This process took place 4 billion years ago. Modern vent microbes still use similar chemical pathways today. They offer a living window into our ancient past. The deep ocean nurtured early life. Fact number 72. Hydrothermal vents produce distinct acoustic signatures underwater. Black smokers are not silent geological features. They generate continuous low-frequency rumbling sounds. The noise comes from escaping high-pressure fluids. Boiling water bubbles collapse rapidly near the vent opening. This collapse creates a phenomenon known as cavitation. Cavitation produces sound waves that travel through the ocean. Researchers use hydrophones to listen to these deep signals. A typical vent produces sounds between 10 and 500 Hz. These frequencies can travel for many kilometers underwater. The pitch changes depending on the chimney structure. Taller chimneys produce slightly lower acoustic resonance frequencies. Scientists recorded these sounds during a 2008 expedition. They mapped an entire vent field using only acoustics. Some predatory fish might use these sounds for navigation. The rumbling guides them through the pitch-black ocean depths. It acts as a natural acoustic beacon for marine life. Changes in sound often precede underwater volcanic eruptions. Listening reveals hidden ocean secrets. Fact number 73. Certain hydrothermal vent shrimp lack traditional compound eyes. The species Rimicaris exoculator lives on mid-Atlantic ridge vents. These deep-sea creatures dwell completely in the dark. Normal vision is useless at 3,000 meters down. Instead, these shrimp evolved a unique dorsal light organ. This organ sits right beneath their transparent carapace. It contains highly sensitive light-detecting pigment cells. The organ cannot form distinct visual images. It only detects faint thermal radiation from the vents. Black smokers emit extremely low levels of infrared light. This faint glow is invisible to human eyes. The shrimp use this glow to avoid boiling water. If they swim too close, they will instantly cook. The dorsal organ guides them to safe feeding zones. Scientists discovered this adaptation in 1989. Researchers brought live shrimp to the surface for study. Bright ship lights permanently blinded the captured specimens. Their delicate sensors were overwhelmed by surface illumination. This proves their extreme sensitivity to faint light. Fact number 74. Hydrothermal vents regulate the magnesium balance of our oceans. Rivers constantly deposit dissolved magnesium into the global sea. Without a removal mechanism, oceans would become highly toxic. Hydrothermal circulation provides this crucial chemical filtration system. Cold seawater seeps deep into the fractured ocean crust. The water approaches the subterranean magma chamber and heats up. As temperatures rise, a vital chemical reaction occurs. Magnesium in the seawater binds with the surrounding basalt. The rock absorbs almost all the dissolved magnesium. The heated fluid then shoots back into the ocean. This exiting vent fluid contains virtually zero magnesium. This continuous cycle purifies the entire ocean volume. It takes about 10 million years to cycle completely. Every drop of ocean water eventually passes through rock. Geologists confirmed this massive filtration process in the 90s. The vents act as the kidneys of the sea. They maintain the precise chemical balance required for life. The deep earth quietly sustains the surface marine biosphere. Fact number 75. Hydrothermal vents likely exist beyond our own planet. Saturn has an icy moon called Enceladus. Cassini studied this moon in 2005. It discovered massive geysers erupting from the southern pole. These plumes contain water vapor and organic compounds. Scientists analyzed the chemistry of these icy plumes. They found tiny silica nanoparticles within the frozen spray. These specific particles only form under very precise conditions. They require hot alkaline water interacting with rocky cores. The required temperature exceeds 90 degrees Celsius. This strongly suggests active hydrothermal vents on the seafloor. Enceladus hides a global ocean beneath its icy crust. Gravitational friction from Saturn generates internal heat. This heat drives the deep-sea hydrothermal circulation. The vents there might resemble our own lost city. Astrobiologists seek extraterrestrial life in these alien oceans. Future missions plan to fly through these plumes again. They will search for complex biological signatures in space. Ocean vents prepare us for exploring other worlds. Fact number 76. Yeti crabs farm their own food near vents. Scientists discovered this crustacean in 2005. It lives along the Pacific-Antarctic ridge. Long claws are covered in pale bristles. These bristles look exactly like thick white hair. The hair serves a highly specialized agricultural purpose. Chemosynthetic bacteria grow densely on these hairy appendages. The crab carefully cultivates this personal bacterial garden. It waves its claws rhythmically over the vent fluid. This waving motion bathes the bacteria in fresh nutrients. Methane and hydrogen sulfide feed the growing microbial colony. Once the bacteria multiply, the crab harvests its crop. It uses specialized mouthparts to scrape the bacteria off. This farming provides a reliable food source. The Yeti crab rarely needs to hunt for prey. It thrives in a highly toxic and extreme environment. The crab measures about 15 centimeters in total length. It lacks functional eyes due to the absolute darkness. Its entire existence revolves around its cultivated bacterial harvest. Fact number 77. Individual hydrothermal chimneys have surprisingly short geological lifespans. Black smokers do not last for millions of years. Most active chimneys only flow for a few decades. Some collapse after just 10 to 20 years. The rapid mineral deposition causes their eventual downfall. Minerals precipitate almost instantly as hot fluid exits. The chimney walls grow thicker with each passing day. Mineral deposits eventually clog the main central vent. The flow of hot fluid slows and finally stops. Without the hot fluid, the surrounding ecosystem dies quickly. Tube worms and crabs must migrate to new vents. The dead chimney becomes a cold monolith. Ocean currents slowly erode the fragile mineral tower. The hollow structure collapses under its own weight. However, new chimneys constantly form in the same field. Magma shifts beneath the crust, opening new fissures. Hot water breaches the seafloor nearby. A new mineral tower begins to grow immediately. The vent ecosystem is dynamic and constantly shifting. Fact number 78. Viruses play a crucial role in hydrothermal vent ecosystems. Deep-sea vents harbor massive populations of microscopic viruses. These are mostly bacteriophages that infect vent bacteria. One drop of vent fluid contains millions of viruses. They are the most abundant biological entities there. These viruses constantly infect and destroy bacterial cells. This destruction releases vital carbon back into the water. Other microbes consume this released cellular material quickly. This process is known as the viral shunt. It prevents any single bacterial strain from dominating completely. Viruses maintain a healthy diversity within the microbial mat. They also transfer genetic material between different bacteria. This horizontal gene transfer accelerates microbial evolution. Bacteria quickly acquire new traits to survive extreme heat. Scientists sequenced vent viral DNA in 2014. They found many completely unknown viral families. These viruses possess unique genes for surviving pressure. Their protein coats remain stable at boiling temperatures. The ocean is a vast reservoir of viral genetics. Fact number 79. Hydrothermal vents face severe threats from deep-sea mining. Inactive vent chimneys are very rich in valuable metals. They contain massive deposits of copper, gold, and zinc. These structures are called seafloor massive sulfide deposits. Mining companies want to harvest these rare resources. Technology requires these metals for batteries and electronics. Nations have already claimed deep-sea mining territories. Heavy machinery would crush the fragile vent ecosystems. Robots would grind the mineral towers into dust. This process creates thick plumes of toxic sediment. Ocean currents would carry this sediment for miles. The dust would smother nearby active vent communities. Filter-feeding tube worms would choke and die. Scientists warn that vent ecosystems recover extremely slowly. A destroyed vent field might take centuries to rebuild. The International Seabed Authority regulates these mining activities. Conservationists urge strict protections for these unique habitats. The loss of biodiversity could be permanent and devastating. We still know very little about these deep environments. Fact number 80. Hydrothermal vent fluids behave uniquely due to extreme density. Superheated fluid shoots upward upon exiting a chimney. This rising column is known as a hydrothermal plume. The vent fluid is initially much lighter than seawater. It rises rapidly through the cold ocean depths. The plume ascends hundreds of meters above the seafloor. It slowly mixes with the surrounding water. The fluid gradually cools down during this ascent. Heavy dissolved metals begin to precipitate as particles. The plume eventually reaches neutral buoyancy. Its density matches the surrounding ocean water exactly. The fluid stops rising and spreads out horizontally. This creates a massive chemical cloud underwater. Currents carry this horizontal plume for thousands of kilometers. Scientists use sensitive chemical sensors to track these plumes. They detect tiny traces of iron and manganese. Following the chemical trail leads them to undiscovered vents. This method helped discover vents in the Indian Ocean. The plumes disperse vital nutrients across the barren seafloor. Fact number 81. Viruses may have originated within deep hydrothermal vents. Researchers study ancient viral lineages in these waters. The extreme heat forces rapid genetic mutations. Viral particles survive intense pressure and total darkness. Scientists found unique viral genomes in 2014. These genomes lack counterparts in surface waters. They infect heat-loving archaea near the vent chimneys. This infection process drives deep-sea genetic diversity. The viruses transfer beneficial genes between different microbes. This horizontal gene transfer accelerates local evolution. Some viruses here have lemon-shaped protein capsids. These strange shapes withstand extreme physical stress. The capsid protects the fragile genetic material inside. Researchers believe these viruses resemble early life forms. They offer clues about precellular evolution on Earth. The vent environment preserves ancient biological mechanisms. Deep-sea viruses remain a largely unexplored scientific frontier. Viral populations regulate the microbial biomass around vents. They prevent any single bacterial strain from dominating. This ecological balance ensures a stable nutrient cycle. The deep ocean harbors billions of these microscopic entities. They silently shape the future of deep-sea marine biology. Fact number 82. The Lost City vent field operates quite differently. Scientists discovered this unique site in the year 2000. It rests on the Atlantis Massif mountain. This area sits deep in the Atlantic Ocean. Unlike black smokers, these vents lack underlying magma. The system relies on a process called serpentinization. Seawater reacts directly with exposed mantle rocks. This chemical reaction generates substantial subsurface heat. It produces highly alkaline fluids rich in hydrogen. The vent chimneys are made of calcium carbonate. They form massive white towers on the seafloor. The tallest structure reaches 60 meters in height. Researchers named this towering formation Poseidon. The fluid temperature remains a moderate 90 degrees Celsius. The surrounding ecosystem lacks typical tube worms. Instead, dense microbial biofilms cover the white limestone. Tiny snails and amphipods graze on these bacterial mats. The lost city represents a completely different biological paradigm. It shows life can thrive without volcanic heat. These carbonate structures grow steadily over thousands of years. It provides clues about the origin of biological life. Fact number 83. Vent animals tolerate incredibly toxic heavy metal concentrations. The hydrothermal fluids carry dissolved lead and cadmium. High levels of arsenic also flow from the crust. Surface marine life would die in this toxic soup. Deep-sea vent organisms evolved specialized survival mechanisms. They produce unique metal-binding proteins inside their cells. These proteins capture dangerous ions before damage occurs. The captured metals are stored in isolated cellular compartments. Some animals excrete the heavy metals through their shells. Other species utilize specialized bacteria for heavy metal detoxification. Scientists study these proteins for medical applications. They hope to develop treatments for human metal poisoning. The vent mussels filter massive volumes of toxic water. Their gills contain high concentrations of these protective enzymes. Researchers measured cadmium levels in vent shrimp tissues. The levels were 100 times normal oceanic baselines. Yet the shrimp suffer no apparent biological harm. This adaptation requires immense cellular energy to maintain. The dark ocean hides remarkable biochemical engineering. These survival traits developed over millions of generations. Fact number 84. Hydrothermal vents exist beneath the freezing Antarctic ice. Scientists found the Kemp caldera vents in 2010. They deployed remotely operated vehicles into the Southern Ocean. The surrounding water temperature hovers near freezing. The vent fluids emerge at nearly 400 degrees. This creates the steepest temperature gradient on Earth. Unique animals inhabit this isolated polar deep-sea environment. Researchers discovered a new species of Yeti crab here. These crabs cluster tightly around the warm mineral chimneys. Their hairy chests cultivate dense gardens of edible bacteria. Seven-armed starfish crawl slowly across the rocky seafloor. Predatory sea anemones attach to the cooling basalt rocks. The Antarctic circumpolar current isolates this biological community. Larvae cannot easily travel to other ocean basins. This isolation drives highly localized evolutionary paths. The polar vents remain largely cut off from global currents. Exploring these frozen depths requires heavily reinforced icebreaker ships. The harsh surface conditions limit scientific research expeditions. Each dive yields completely unknown biological specimens. The dark waters hide many more undiscovered vent fields. Freezing pressure preserves this delicate biological balance perfectly. Fact number 85. Hydrothermal vents regulate the chemistry of the global ocean. The entire ocean volume circulates through the oceanic crust. This massive filtration process takes about 100,000 years. Cold seawater seeps into deep cracks in the seafloor. The water travels kilometers down toward the hot magma. Extreme heat fundamentally alters the composition of the water. The rock absorbs all the magnesium from the seawater. The fluid dissolves iron and manganese from the crust. The heated water eventually shoots back into the ocean. This continuous cycle maintains the chemical balance of seawater. Without vents, the ocean would become increasingly rich in magnesium. The mineral deposits also consume vast amounts of dissolved oxygen. This chemical exchange impacts global marine nutrient distribution. The iron released by vents fertilizes distant surface waters. Phytoplankton rely on this trace iron for photosynthesis. Deep-sea vents directly support life near the ocean surface. Earth operates as one massive interconnected chemical system. Scientists constantly monitor these vital chemical fluxes. This continuous chemical exchange sustains global marine food webs. The abyss acts as the planetary chemical engine. Fact number 86. Hydrothermal vents generate distinct acoustic signatures in the dark. The violent expulsion of hot fluids creates continuous noise. Expanding mineral bubbles pop rapidly in the cold water. Turbulent flow against the chimney walls produces deep rumbles. Scientists use sensitive hydrophones to record these underwater sounds. The acoustic frequencies range from 10 to 500 Hz. Different types of vents produce completely different sound profiles. Black smokers generate a loud and chaotic acoustic spectrum. White smokers emit a softer and more rhythmic hiss. Researchers can identify vent fields by listening to the ocean. Sound travels incredibly well through dense deep-sea water. These acoustic signals guide robotic explorers to new discoveries. The background noise of the ocean often masks these sounds. Sophisticated computer algorithms filter out passing ships and whales. The isolated sound of a vent resembles a roaring furnace. Some marine animals might use these sounds for navigation. Larvae could potentially hear the vents from kilometers away. This acoustic beacon helps them find suitable habitats. The deep ocean is never truly silent or still. These acoustic rhythms echo through the dark abyssal plains. Fact number 87. Fossilized hydrothermal vents exist on dry land today. Tectonic forces pushed ancient oceanic crust onto the continents. Geologists call these displaced crustal rock formations archaeolites. The Ural Mountains hold 400-million-year-old vent fossils. These ancient chimneys turned entirely to solid rock. Scientists slice these rocks to study past marine ecosystems. They find perfectly preserved fossilized worm tubes inside. The biological structures were replaced by shiny iron pyrite. This fool's gold preserves microscopic details of ancient bacteria. The fossil record shows remarkable evolutionary continuity over time. The basic structure of vent communities has not changed. Ancient mollusks lived exactly like their modern deep-sea descendants. These terrestrial fossils provide easy access for detailed geological study. Researchers map entire extinct vent fields in terrestrial deserts. The fossils prove that vents operated during the Devonian period. They offer a rare window into prehistoric deep ocean chemistry. Ancient oceans harbored the same dark thermal oases. Studying these rocks requires only a simple geological hammer. Dry land hides many secrets of the ancient abyss. Geologists continue hunting for more of these ancient structures. They tell a story of incredible biological endurance. Fact number 88. Hydrothermal plumes strongly influence deep ocean circulation patterns. The extreme heat creates massive underwater thermal updrafts. Millions of gallons of hot fluid rise continuously. These towering thermal plumes can ascend 300 meters. They eventually hit a layer of equal water density. The mineral-rich water then spreads horizontally across the ocean. This lateral spreading can reach thousands of kilometers. The rising heat pulls surrounding cold water inward. This creates localized deep-sea currents near the vent fields. These currents transport biological larvae to new distant habitats. The thermal energy contributes to global thermohaline circulation. This massive conveyor belt moves water around the planet. Vents inject roughly 3 terawatts of heat into the ocean. This immense thermal energy prevents the deep ocean from stagnating. Scientists track these chemical plumes using sensitive optical sensors. The spreading clouds of particles scatter the sensor light. Mapping these plumes reveals the hidden topography of the seafloor. The deep currents flow silently in the eternal darkness. They shape the physical environment of the abyssal plains. Fact number 89. The scalyfoot snail relies on a complex symbiotic relationship. This unique gastropod houses bacteria in its esophageal gland. This specialized gland takes up 9% of its body. The snail lives exclusively near deep Indian Ocean vents. The internal bacteria produce organic food from toxic sulfides. The snail lacks a traditional digestive system for eating. It absorbs the bacterial nutrients directly into its bloodstream. In return, the snail provides a safe internal environment. Its gills extract necessary oxygen and hydrogen sulfide. A specialized circulatory system delivers these raw materials inward. The snail's heart is massive compared to its body size. This large heart pumps blood efficiently to the hungry bacteria. The biological partnership represents a perfect evolutionary compromise. Neither organism can survive without the other in this environment. The snail even uses vent minerals to build its shell. It incorporates iron sulfides directly into its outer armor. This creates a dark metallic shell unique in nature. The deep sea demands such extreme biological cooperation. Scientists continually study this remarkable iron-plated deep-sea creature. Its survival strategy remains unmatched in the animal kingdom. Fact number 90. Hydrothermal vents contain massive deposits of valuable rare minerals. Seafloor massive sulfides accumulate over thousands of uninterrupted years. These deposits hold vast quantities of copper and gold. High concentrations of zinc and silver also precipitate here. The mineral ores are significantly richer than terrestrial mines. Mining companies currently hold numerous deep-sea exploration leases. They design massive robotic machines to harvest the seafloor. The proposed mining process raises severe environmental concerns. Excavation would completely destroy the delicate vent chimney structures. The mining process generates thick clouds of suspended sediment. This artificial plume could smother surrounding deep-sea biological communities. Many vent species live nowhere else on the planet. Destroying a single vent field could cause immediate extinctions. Scientists urge caution before any commercial extraction begins. The International Seabed Authority regulates these deep ocean territories. Researchers are rushing to study these pristine habitats beforehand. The dark mineral wealth poses a threat to deep-sea life. The future of these silent ecosystems remains highly uncertain. Preserving these underwater wonders requires international legal cooperation. The deep sea belongs to no single human nation. Fact number 91. Scientists carefully measure the fluid output of black smokers. They use acoustic Doppler current profilers for this task. A single large chimney expels massive volumes of water. Flow rates frequently exceed 100 liters per second. This translates to millions of gallons every single day. The rising plumes create powerful upward thermal water currents. These currents transport dissolved minerals high into the ocean. Researchers track these thermal plumes across vast oceanic distances. The total global water flux through vents is staggering. The entire ocean volume cycles through the oceanic crust. This complete circulation takes roughly 20 million years. This continuous pumping acts as a global chemical regulator. It maintains the precise salinity balance of global oceans. Without this flow, seawater chemistry would be radically altered. The vents essentially function as massive planetary filtration systems. They filter and recycle the deep sea water continuously. Data reveals complex turbulence patterns near the vent orifice. Fact number 92. Hydrothermal vents play a crucial role in carbon cycling. Deep ocean fissures release enormous quantities of dissolved methane. Methane is a highly potent greenhouse gas on Earth. However, very little of this methane reaches the atmosphere. Specialized microbes called methanotrophs consume this gas rapidly. These bacteria live in dense mats around the vents. They oxidize the methane to produce their own energy. This biological filter traps carbon deep within the ocean. Scientists estimate vents release millions of tons of methane. The microbial communities consume up to 90% locally. This process significantly regulates the global climate system over time. Carbon is eventually buried in the surrounding seafloor sediment. Researchers study these microbes to understand global warming mitigation. The efficiency of this deep-sea filter is remarkable. It demonstrates a perfectly balanced biological and geological system. Any disruption to these microbes could release trapped carbon. The deep sea acts as a silent climate guardian. Fact number 93. Hydrothermal vents likely exist beyond our own home planet. Saturn possesses a small icy moon known as Enceladus. The Cassini spacecraft analyzed water plumes erupting from Enceladus. These massive plumes shoot into space from the South Pole. Scientists detected silica nanoparticles within these frozen water jets. On Earth, such particles only form in hydrothermal vents. The process requires hot alkaline water meeting cold temperatures. Cassini also detected significant amounts of molecular hydrogen gas. Hydrogen is a primary energy source for vent microbes. These findings strongly suggest active vents on the Moon. A liquid water ocean sloshes beneath the icy crust. Tidal friction from Saturn generates the necessary internal heat. This extraterrestrial ocean might harbor simple alien biological life. Enceladus remains a primary target for future astrobiology missions. Researchers design new probes to sample these plumes directly. They hope to find complex organic molecules or cells. The dark ocean of Enceladus mirrors our own abyss. Fact number 94. The oldest fossils on Earth might originate from vents. Geologists discovered ancient rocks in northern Quebec in Canada. This formation is called the Nave-Waugetuk supracrustal belt. These rocks date back nearly 4 billion years ago. Researchers found microscopic tubes and filaments within the quartz. These structures contain significant amounts of iron oxide minerals. They perfectly match the shapes of modern vent bacteria. The rock layers also show chemical signatures of oceans. This implies life thrived around vents during Earth's infancy. The planet was still suffering from heavy asteroid bombardments. The surface was completely hostile to any biological survival. Deep underwater vents provided a safe and stable refuge. These fossilized microbes fed on iron and sulfur compounds. Their discovery pushed back the timeline of biological origins. It suggests life emerges quickly once liquid water exists. Scientists use advanced electron microscopes to study these fossils. They map the precise atomic structure of the filaments. This ancient stone holds the earliest memory of life. Fact number 95. Alkaline hydrothermal vents are central to origin of life theories. These specific vents differ greatly from volcanic black smokers. They form through a slow chemical process called serpentinization. Seawater reacts with mantle rocks to produce alkaline fluids. This reaction naturally creates microscopic porous structures in rocks. These tiny mineral pores acted as primitive biological cells. They concentrated organic molecules within their protective rocky walls. The vent fluid creates a natural proton gradient across minerals. Modern cells use similar proton gradients to generate energy. Scientists believe the last universal common ancestor evolved here. This theoretical organism is often referred to as LUCA. Genetic studies show LUCA depended on hydrogen and iron. These elements are abundant in alkaline hydrothermal vent systems. LUCA lived in a hot and completely oxygen-free environment. Every living creature on Earth descends from this microbe. The transition from geochemistry to biochemistry occurred in darkness. Researchers simulate these ancient vent conditions in modern laboratories. They successfully create basic organic molecules from simple gases. Fact number 96. Hydrothermal vents face a modern threat from human industry. The chimneys contain massive deposits of rare earth metals. These structures are formally known as polymetallic massive sulfides. They hold high concentrations of copper, gold, and zinc. Mining companies want to harvest these valuable mineral resources. The demand for metals for green technology is rising. Electric vehicle batteries require massive amounts of these elements. The International Seabed Authority regulates these deep ocean areas. They issue exploration contracts for the Clarion-Clipperton Zone. Biologists warn that mining could destroy fragile vent ecosystems. Many vent species exist nowhere else on the planet. Removing the chimneys would instantly eradicate entire biological communities. The sediment plumes from mining machines could smother life. Noise pollution would disrupt the communication of deep species. Recovery of these slow-growing ecosystems might take several decades. Some scientists advocate for total protection of active vents. They propose limiting mining to extinct and dormant chimneys. The debate balances ecological preservation against global resource needs. Fact number 97. Hydrothermal vents generate their own unique acoustic underwater signatures. The deep ocean is rarely a completely silent place. Boiling fluids and escaping gases create constant low murmurs. Mineral chimneys crack and pop as they rapidly cool. Scientists drop hydrophones to the seafloor to record sounds. Active vents produce a continuous broadband acoustic noise spectrum. The frequency peaks often range between 10 and 50 Hz. This low-frequency sound travels incredibly far underwater. Some researchers believe marine animals use these acoustic beacons. Deep-sea larvae might follow the noise to settle. The sound guides them to newly formed vent habitats. Different types of vents produce distinctly different acoustic profiles. Black smokers sound completely different from cooler white smokers. Acoustic monitoring helps scientists detect sudden undersea volcanic eruptions. Networks of underwater microphones listen to the abyss constantly. They capture the violent birth of new hydrothermal chimneys. The recordings sound like distant thunderstorms rolling past. This acoustic data reveals the hidden dynamics of vents. Fact number 98. Viruses are the most abundant biological entities at vents. A single milliliter of vent fluid contains millions of viruses. These deep-sea viruses are entirely harmless to humans. They specifically target the local bacteria and archaea populations. Viral infections constantly kill off large portions of microbes. This microscopic warfare releases vital nutrients back into water. The process is called the viral shunt in ecology. It sustains the delicate food web of the abyss. Vent viruses also drive rapid evolutionary changes in bacteria. They carry genetic material from one host to another. This horizontal gene transfer helps microbes adapt to toxins. Scientists discover completely novel viral genomes in these fluids. Many vent viruses possess unique structural adaptations for heat. Their protein coats remain stable at extremely high temperatures. Some viruses integrate their DNA into the host genome. They wait for environmental conditions to become perfectly optimal. Then they multiply and burst forth from the host. Studying these viromes expands our understanding of genetic diversity. Fact number 99. The Aurora hydrothermal field hides beneath thick Arctic ice. It sits on the Gackel Ridge in the Arctic Ocean. Scientists first detected chemical plume signals here in 2014. They returned in 2021 for sampling. Exploring this region requires heavy icebreakers and autonomous submarines. The vent field lies 4,000 meters below the ice. This extreme isolation creates a highly unique biological ecosystem. The Aurora field features massive mounds of polymetallic sulfides. Researchers discovered entirely new species of deep-sea amphipods. The biological communities differ from those in the Atlantic. Thick ice cover prevents any surface organic matter sinking. The ecosystem relies 100% on chemosynthetic energy. Submersibles captured stunning high-definition video of the vents. Golden mineral spires rise from the dark freezing seafloor. The discovery proves vents exist in all global oceans. It also tests technologies needed for exploring icy moons. Navigating under moving ice floes is incredibly dangerous work. The successful mission represents a triumph of marine engineering. Fact number 100. Hydrothermal vents are highly ephemeral structures in the ocean. They do not last forever on the dark seafloor. A typical black smoker might remain active for decades. Some larger fields persist for thousands of years continuously. Eventually, shifting tectonic plates alter the underlying plumbing system. Magma chambers cool down and stop heating the water. Mineral deposits slowly clog the narrow subterranean fluid channels. When the hot fluid stops flowing, the ecosystem collapses. The thriving bacterial mats quickly wither away and die. Tube worms and clams starve without their chemosynthetic food. Scavengers arrive to consume the decaying remains of life. The towering mineral chimneys slowly dissolve into the seawater. They eventually collapse into piles of lifeless metallic rubble. However, new vents constantly form in other volcanic regions. The deep-sea larvae drift endlessly to find them. This cycle of birth and death shapes ocean ecology. It represents the dynamic and ever-changing Earth crust. The destruction of one vent brings life to another. We have reached the end of our deep journey. 100 facts about hydrothermal vents now rest within you. We traveled from the sunlit surface to the darkest abyss. We witnessed towering chimneys of gold and black smoke. We met creatures that defy the laws of biology. These dark ecosystems teach us about the resilience of life. They show us how life thrives in extreme isolation. The deep ocean is not a barren or empty wasteland. It is a vibrant world fueled by the Earth itself. Heat from the planetary core sustains endless biological wonders. These hidden oases remind us of our planet's profound complexity. The ocean breathes through these fractured volcanic crusts. Thank you for joining this long and peaceful expedition. Your curiosity brought light to the deepest ocean trenches. Now it is time to leave the abyss behind. Let the rhythmic currents carry your thoughts away slowly. The deep sea will continue its quiet and steady work. The blind shrimp will dance around the black smokers. You can rest now knowing the ocean is alive. Release any remaining tension in your tired muscles today. Drift into a calm and deeply restorative sleep cycle. Good night, dear listener. Sleep well.